Hello! In this video, we are going to prove the following theorem. Every positive integer is a positive real number. Now in this series, we are using a list of 10 axioms for the real number system, and I'll leave that list of axioms in the description below. Now, in our real number system, we are given that the positive real numbers is a subset of the real numbers, and it satisfies axioms 8 and 9. Now, axiom 8 says the following. It says for all positive real numbers x and y, we have x plus y as a positive real number and x times y as a positive real number. And we use the set of positive real numbers to define the greater than relation. And the way we defined it was, given any two real numbers a and b, we say a is greater than b if a minus b is a positive real number. And from this definition, we proved the following two facts about the greater than relation. We have proven for all real numbers x is a positive real number if and only if x is greater than 0, and we've proven 1 is greater than 0. Now, in regards to the positive integers, we defined the positive integers as a subset of the real numbers. And the way we defined it was, we first defined a special type of subset of the real numbers called an inductive set. And from there, we defined the positive integers as the set of real numbers which belong to every inductive set. Now, the most important part was, we showed that the principle of mathematical induction holds for the positive integers. So we're going to prove this statement using induction, because all this statement means is, for all positive integers n, we have n is a positive real number. So we're going to prove this statement using induction. So let's start with the base case. In the base case, we're trying to show that this statement is true in the case where n is equal to 1. So we're trying to show that 1 is a positive real number. And to see how that happens, well, let's first note, by star star, we know that 1 is greater than 0. But then, by star, if we take x to be 1, well then we have 1 is a positive real number if and only if 1 is greater than 0. So, since we know 1 is greater than 0, we can conclude that 1 is a positive real number. And that is exactly what we wanted to show. So this completes the base case. Now let's move on to the induction step. In the induction step, we give ourselves an arbitrary positive integer n, and we assume that this statement is true for that arbitrary positive integer n. From here, the whole goal of the induction step is to show that this statement is also true for n plus 1. So really, we want to show that n plus 1 is a positive real number. Now, we know that n is a positive real number, and from the base case, we know that 1 is a positive real number. So then, by axiom 8, since n is a positive real number and 1 is a positive real number, that implies n plus 1 is a positive real number. And that is exactly what we wanted to show. So this completes the induction step. Because we've completed both the base case and the induction step, this closes the induction. So by mathematical induction, we have shown for all positive integers n, we have n is a positive real number. And that is precisely what it means for the positive integers to be a subset of the positive real numbers. And so this completes the proof. And so yeah, that's pretty much it for this video.